if cosecant 39 degrees is equal to x, then what is the value of 1 by cosecant square 51 plus sine square 39 plus tan square 51 minus 1 by sine square 51 into secant square 39. Yeah. So just keep this in mind that cosecant square 39 is equal to x. This we will use it towards the end. Now look at the equation given here, right? The expression given here. The first term is 1 by cosecant square 51. You know that 1 by cos theta or 1 by cosecant theta is sine theta. Yeah, 1 by cosecant theta is sine theta. So 1 by cosecant square 51 will become sine squared 51 degrees plus second term as it is, let's take it as sine squared 39 degrees plus the third term is tan squared 51 degrees minus, look at the next part here, right? This is like 1 by sine squared 51 into secant squared 39. Now you know that what can we do here? I think I'm just trying to look at the best way to simplify this, right? Sine square 51 into secant square 39. Yeah, so what I'll do is, see, in the denominator we have got the secant square 39, right? Let me take that in the numerator. So 1 by secant square 39 becomes cos square 39. So this becomes cos squared 39 divided by sine squared 51. Divided by sine squared 51. Yeah? Cos square 39. See, 1 by secant square 39 is cos square 39. And sine square 51 is in the denominator itself. We are not disturbing that. So now simplify what happens. If you see, sine square 51 will become cos squared 39. Yes or no? Sine square 51 will become cos squared 39. Because this is like sine of 90 minus 51. Sine of 90 minus 51 is cos 39. So cos squared 39. So this will be like cos squared 39 degrees plus sine squared 39 degrees plus let's take tan square 51 as it is. Tan squared 51 minus, what can be done with this? Cosecant square 39 can be taken as sine square 51. Yeah, cosecant square 39 is sine square 51. Again the same argument, right? Cosecant square 39 is cosecant of, sorry, not cosecant, I'm reading it wrong. Cos square 39. Cos square 39 can be taken as sine square 51. Because cos 39 is cos of 90 minus 51. Cos of 90 minus 51 is sine 51. So this becomes sine square 51. Sine square 51 by sine square 51. So that makes it 1. I can directly take it as 1, but I'm just explaining the step-by-step process. So if you see, this is equal to 1. Yes or no? This is equal to 1. Sine square theta plus cos square theta equals to 1. Sine square by 51 by sine square 51 is also equal to 1. So this 1 and minus 1. Minus 1, right? 1 and minus 1 gets cancelled. This and this gets cancelled. You're able to follow. Sine square theta plus cos square theta is 1. Minus sine square 51 by sine square 51 is minus 1. So plus 1 and minus 1 gets cancelled. We are left with what? Tan squared 51. Tan squared 51. Now try to reduce this tan square 51 in terms of cosecant square theta if possible. Yeah, or otherwise draw the trigonometric right angle triangle. We have discussed this, right? This approach is very important. He says cosecant 39. Let's assume this is 39 degrees. Right? What is cosecant 39? Cosecant 39 is hypotenuse by opposite. Yes or no? So hypotenuse by opposite is, see, this can be taken as x by 1, which is like hypotenuse by opposite. Yes or no? Cosecant theta is hypotenuse by opposite. So hypotenuse is x, opposite is opposite is this, opposite is 1. So what should this be? Evaluate this. See, we know that 1 square plus question mark square equals to x square. So from this question mark comes out to be root over x square minus 1. Yeah, so this is equal to root over x square minus 1. So now we know all the three sides of the right angle triangle. 1x root over x square minus 1. What is he asking us to find out? Tan square 51. Okay, tan square 51 can be taken as, again, see, this is 39 degrees, understand? Cosecant 39 is given, but what we have here is 51. So convert this 51 to 39. See, tan square 51 will become cot square 39, right? Yes or no? Cot square 39. What is cot theta? Cot theta is adjacent by opposite, right? Adjacent by opposite. So this, you're able to follow. Cot theta is adjacent by opposite. So adjacent side is x square by root over x square minus 1. By opposite side is 1. This whole squared. So that leaves us as x square minus 1, option 3. All right, simple. Just play with those ratios, consider this right angle triangle and simplify to get the answer. This side we have considered as question mark. By applying Pythagoras theorem, we get this as x square minus 1, right? This is a calculation. So he's asked us to find out tan square 51 indirectly. Tan square 51 is cot square 39. Now cot theta is adjacent side by opposite side. Adjacent side root over x square minus 1. Opposite side is 1. So root over x square minus 1 by 1. But this is cot square, so whole square. So that's this and this gets cancelled. So we are left with x square minus 1, which is option 3. We can also convert cot to cosecant. I mean, you know that cot square theta is equal to cosecant square theta minus 1. So that also can be done. I mean, if you don't want to consider the right angle triangle, if this is not what you're willing to do, then the other process is as follows. I'll explain you the other process in a different color so that you can understand, right? After this step, after you have got cot square 39, see, cot squared, that in fact is easier. Cot square 39 degrees can be taken as cosecant square 39 degrees minus 1. This is again a very important trigonometric identity. Cot square theta equals to cosecant square theta minus 1. Cosecant theta is also already given to us, x. So this becomes x squared minus 1. So that also gives you the same answer, option 3. Yeah, so either of the approaches will be fine. Okay, option 3, x squared minus 1. Again, there are two ways of doing it. Either you can follow a regular method. If you are confident that yes, you can solve it using regular method within no time, go for it. Like in 15, 20 seconds or 30 seconds, just go for it. Otherwise, if you think it's going to be complex, go for substitution, right? Now, what's the regular method of solving it, by the way? Let's try it differently this time, right? This time, let's solve it using regular method first. So what happens? How do you solve it using regular method? See, I think I'll in all these cases, I'll try to avoid denominators first. So convert the denominators, try to eliminate the denominators. How can you do that? 1 by cosecant square theta is like sine square theta, right? You know that 1 by cosecant theta is sine theta. So 1 by cosecant square theta is sine square theta. So 9 by cosecant square theta will become 9 sine square theta plus 4 cos square theta as it is. I think it's already in a simplified form, so don't need to worry about that. Plus the last term here. Now 1 plus tan square theta. See, the first identity that we have used is 1 by cosecant theta equals to sine theta. So 1 by cosecant square theta will be sine square theta. Now next is here in the denominator we've got 1 plus tan square theta. You know that 1 plus tan square theta is secant square theta. Yes or no? Secant square theta minus tan square theta equals to 1, right? So 1 plus tan square theta will be equal to secant square theta. So this will become 5 by secant square theta. But again, I know that 1 by secant theta is cos theta. So overall, this will become 5 by secant square theta, which is 5 cos square theta. Again, if we see 4 cos square theta plus 5 cos square theta is 9 cos square theta. So what do we have finally? We have got 9 sine square theta plus 9 cos square theta. And by taking 9 common, what do we get? 9 times of sine square theta plus cos square theta. The other identity is sine square theta plus cos square theta equals to 1. So if we take sine 9 common there, we'll have 9 into 1, which is 9. So final answer is 9, option 3. But if you do not want to do this, go for substitution. Substitute some value in place of theta and verify. You can take theta equals 30, 90, 45, 60, 0, whichever you think will give you a proper result, right? So shall we try substituting something? Let's substitute theta equals to 30. I'll do it in a different color, right? Theta equals to 30. So you see the solution that we have done in black here involves multiple steps and many identities there. But now let's say theta equals to 30. What happens if you take theta equals to 30 degrees? Substitute. Now cosecant square 30, right? What will happen? Then this will become 9 by cosecant square 30 plus 4 cos square 30 plus 5 by 1 plus tan square 30. In fact, this time substitution looks to be complex because the regular method was very easy, right? Easy simplification. But try it out. What we are trying to verify is, will substitution give the answer in this case or not? It should give. Let's try it out. So simplify now. What happens? The first term here is 9 by cosecant square theta. What cosecant square 30? What is cosecant 30? See, we know that sine 30 is 1 by 2. If sine 30 is 1 by 2, cosecant 30 will be 2. And cosecant square 30 will be 4. So this becomes 9 by 4. So first term is 9 by 4 plus cos square 30. Cos 30 is root 3 by 2. So cos square 30 will be root 3 by 2 whole square. which is like 3 by 4. 4 into 3 by 4. 4 into 3 by 4. Plus the last term now. 5 by 1 plus tan square 30. What is tan square 30? See, tan 30 is 1 by root 3, right? Tan 30 is 1 by root 3. So tan square 30 will be 1 by 3. So 5 by 1 plus 1 by 3. 1 plus 1 by 3 will be 4 by 3. 1 plus 1 by 3 will be 4 by 3. 5 by 4 by 3. That becomes 15 by 4. Yes or no? Now simplify. 4 and 4 gets cancelled here. 9 by 4 plus 15 by 4. 9 by 4 plus 15 by 4 is like 24 by 4. 24 by 4 is 6. 6 plus 3 is giving you 9. Yes or no? So 9 is the answer. Whether you follow the regular method or substitution, you'll get the same answer, 9. Again, this may look lengthy, this may look complex this time. Substitution may look complex, but more than the complexity, the point that I'm trying to prove here is substitution works in this case as well. Although the regular method is easier to follow, substitution works. It does work, right?